a new planet with very similar properties to Earth has been found. Experts are speculating that it may be the perfect home away from home, and may even host extraterrestrial life forms already. But then, amid this excitement, members of the scientific community stumbled upon another planet that's possibly even better and more conducive for humans than Earth. What are these new planets, and where were they discovered? What signs and attributes make experts believe these planets are conducive for us? What are the chances of finding other intelligent life forms living on these planets? Join us in this video as NASA just discovered a new planet better for life than Earth. With various issues like global warming, climate change, pandemics, and all sorts of natural disasters, scientific experts believe that our Earth is slowly giving up the ghost. It's only a matter of time before some chaotic planetary disaster occurs and wipes out all of humanity. With that in mind, scientists have been on the lookout for a planet in the cosmos that we can call home, just like Earth. Initially, the idea was to find a planet within our solar system that could be habitable for us. This curiosity was what prompted the scientific community in the middle and late 1900s to send probes to planets in our solar system. Since Jupiter and Venus were too close to the Sun, the only viable candidates were Mars, Jupiter, Saturn, and Uranus. However, it was realized much later that none of these could be good enough for humans. Jupiter has the most chaotic weather and atmosphere of all the planets in our solar system. Saturn's atmosphere is heavily loaded with hydrogen, and it also has something called helium rain. Uranus lacks oxygen in its atmosphere, so it'll be practically impossible for us to breathe. The closest candidate so far is Mars. Although it's an arid dry land with dust storms and radiation, experts and space enthusiasts like Elon Musk are confident that it may be possible to make this planet conducive for humans. Some efforts are even being made to set up a base on Mars in the coming years. But the truth is that building a Martian base won't be easy. Such a base would have to simulate the conditions on Earth in terms of oxygen, gravity, water temperature, air pressure, and so on. And so, accomplishing such an endeavor would take billions or even trillions of dollars. It would be 10 times much easier to find a perfect planet with all the right conditions somewhere in the cosmos, rather than transforming the wrong planet into the perfect one. This is why experts have turned their sights to the near and distant parts of the cosmos to see if there is a planet that is just like Earth, or maybe even better. In order to make the search for a suitable substitute planet much easier, scientists have created something they call the Earth Similarity Index. This index uses various parameters like temperature and atmospheric pressure to see just how much a planet resembles Earth and has the potential to sustain life. The index ranges from 0.0 to 1. The higher the number, the more similar a planet is to ours. In other words, a planet with a similarity index of 0.9 is very identical to Earth. Thanks to several advancements in technology, scientists have been able to peek into the innermost parts of the cosmos to uncover some high-potential candidates for planets that are habitable for humans. Astronomers have found a couple of exoplanets and moons with striking similarities to Earth. One such planet was found in 2019, called Teegarden B. This planet is one of the closest possibly habitable planets to Earth, located about 12.4 light-years away from us. It has a mass of 1.05 Earths, meaning it is nearly the same mass as Earth. Teegarden B orbits around an M-type star called Teegarden. M-type stars are red dwarf stars. These types of stars are relatively cool, having a surface temperature of less than 3,600 Kelvin. Teegarden star is 10 times less massive than our Sun, with a temperature of about 2,700 degrees. However, despite its seemingly low temperature, the red dwarf star can still provide enough heat for its two planets, Teegarden B and C. Teegarden B orbits its star at a distance of 0.0252 astronomical units. Teegarden C, the only other planet in this solar system, has an orbiting distance of 0.04 astronomical units and takes about 11 days to complete one orbit. The two planets are similar in characteristics and closely mirror the conditions on planet Earth. Interestingly, both of these planets are situated in the habitable zone of their star. A habitable zone is the distance from a star in which liquid water may form a pool on the surface of any of its orbiting planets. If a planet is too far, it would be too cold, and water would get frozen. If a planet is too close, it would be too hot, and water would be evaporated. For instance, the planet Neptune is filled with frozen water, mostly due to its far distance from our Sun. Other close planets like Venus are completely dry of water, even in its atmosphere. Earth is one of the few planets in the cosmos that is located at just the right distance from its star. However, the discovery of Teegarden B and C proves that Earth is not alone in this regard. Overall, Teegarden B seems much more promising. Using the Earth Similarity Index, Teegarden B gave a score of 0.95 ESI, meaning it's almost 100% like Earth. So far, this planet remains the most Earth-like planet discovered. However, certain uncertainties exist, such as air pressure and temperature. Scientists estimate that the exoplanet may have surface temperatures ranging from 0 degrees to 50 degrees Celsius. But then, if its atmosphere is just like Earth's, its surface temperature could be around 28 degrees Celsius. Speaking of Teegarden C, given that it is farther from its star, it has more chances of being too cold and unsuitable for habitation. Scientific experts estimate that there is only a 3% chance of having a warm surface temperature. In fact, it is believed that this planet's atmosphere is more similar to that of Mars, with temperatures of around minus 47 degrees Celsius. Considering all, Teegarden C ended up with a 0.68 ESI score. As of now, researchers are not exactly sure what the atmospheres of Teegarden B and C are. Both these planets are tidally locked to their star. Hence, scientists estimate that they may have atmospheres with densities between 13 to 17 times that of Earth's. There's a lot of speculation over these two planets. Many theorize that they may just be what we need to call a new home, if and when our Earth gets wrecked by a planetary disaster. But then, many other members of the scientific community are contemplating another possibility, the possibility of these planets hosting extraterrestrial life forms. You see, for long, we've pondered on the question of whether or not we're the only species in the universe. This question has been the major driving force of astronomy and cosmology for centuries. However, in our digging of the cosmic depth so far, no alien civilization has been encountered. Also, no one star or planet has been found that seems to have all the right conditions for hosting extraterrestrial life. The only planets suspected to be viable are those with favorable temperatures and atmosphere, as well as those located in the habitable zones of their stars where water exists. Water is important for any life form. It's just like they say, water is life. Scientists know that anywhere there is water in the universe, there's life there. This is why planets like Teegarden B usually become the center of attention when scientists want to seek out planets where aliens may be hiding. However, Teegarden B isn't alone here. There are other planets that are suspected to be very habitable for extraterrestrial life forms. In fact, there's one planetary system that experts hold in higher esteem than Teegarden in this regard, the TOI 700 planetary system. The TOI planetary system is a star system located in the constellation Dorado. It has 4 planets, 2 of which are in the star's habitable zone. The most promising candidates here are the TOI 700D and TOI 700E. Both of these planets have similar masses to Earth, but with a rocky surface. TOI 700E is about 95% the size of Earth, with an orbital period of 28 days. TOI 700D, on the other hand, is about 105 the size of Earth, with an orbital period of 37 days. The interesting thing about the TOI 700 star system is that it has been around for more than 1.5 billion years. This means it is just a few billion years younger than our solar system, which is aged 4.5 billion years. Going by the cosmic calendar, 1.5 billion years is enough time for biological life forms to appear and evolve on a planet. Many experts speculate that there may be a rich biosphere within TOI 700E and 700D. It could be a game changer if the two planets also have an atmosphere that is warmer than the Earth's average temperature. Such an atmosphere would not only be conducive for us, but also for alien species with similar biological characteristics. Most likely, if we were to discover life forms on any of these planets, they would likely resemble the life forms found here on Earth. But all that is just speculation. For now, until we can find a way to peek into this planet's atmosphere and surface, we may never know what kinds of life forms it hosts. It is theoretically possible that similar life forms can exist on different planets scattered across the cosmos. But then, there is still so much we don't know about the universe. For all we know, the principles of evolution may work very differently on other planets compared to how it did on Earth. Evolution is considered a universal characteristic, just like gravity. The theory of evolutionary convergence explains that unrelated species can evolve similar adaptations if they encounter similar environmental challenges. Take, for instance, creatures like crocodiles that have evolved to swim and breathe underwater. If species like this exist on planets largely dominated by water, such species too would evolve to breathe and swim underwater. But then, how they evolve may differ. While some aquatic animals have evolved with gills, some haven't. Also, birds, insects, mammals, and other flying creatures have all evolved different ways to make the air their home. Birds fly by flapping their wings, but mammals like flying squirrels fly by, spreading their loose skin like a canopy to glide from tree to tree. Each creature has its own unique means of flying or soaring. There's a high chance that this scenario is playing out on other planets in the cosmos that have biolife too. There's also a chance that some of these planets may develop complex forms of biolife. Such complex biolife forms would be totally different from anything we've seen or known on our planet. Usually, conditions such as temperature, atmospheric pressure, and access to water may influence the complexity of these life forms, as they would evolve in strange ways to adapt to their environments. Scientists and researchers are keeping an open mind because there's a possibility of discovering biolife that's unlike anything we've ever seen before. Even on Earth, certain organisms have the weirdest features and survive in the most extreme conditions. These types of life forms can serve as models for the unusual life forms that may potentially exist on other distant habitable planets. So far, our search for extraterrestrial life has mainly focused on planets with close similarities to Earth. You may wonder, what if we were to look at things from a different perspective? What if, instead of looking for signs of life as we know it, we sought for something else, perhaps life as we don't know it? Given the fact that we know so little about our universe, it will not be out of order to imagine that there may be distinct extreme biolife forms lurking deep in some of the planets we've labeled as uninhabitable. Whether it is high radiation, excessive elements, high temperature, or extreme weather, there could be species out there that thrive in these conditions or even find them appropriate. A few years ago, astronomers discovered a new class of planets called Haitian exoplanets that may be able to support life. The planets are larger, hot, and covered with oceans, thereby allowing for a larger habitable zone compared to Earth. Some of these planets have atmospheric pressures reaching almost 200 degrees Celsius. These planets tick the boxes in terms of having a substantial amount of water. However, given the atmospheric and planetary conditions, any kind of bio-life that exists in these worlds would be far different from what we know. One interesting planet in this new class of planets is the K218b. The planet was discovered in 2015. It is one of the hundreds of planets found by NASA's Kepler Space Telescope. Just so you know, the Kepler Space Telescope is a telescope launched by NASA in 2009 to seek out Earth-sized planets orbiting stars in the nearby regions of the cosmos. It was named after astronomer Johannes Kepler. The telescope was launched into a heliocentric orbit, where it orbits the Sun, while slowly drifting farther and farther away from Earth as it scans the cosmos. Thanks to Kepler, we were able to find that about 25 to 50% of the stars we see in the night sky potentially have small, rocky planets similar in size to Earth. Kepler also showed us several of these planets located within the habitable zone of their parent stars. The K218b is one of such stars. Located about 124 light-years away from Earth in the constellation, Leo stands this interesting planet. It's like a mini Neptune orbiting a dim red dwarf star. Many researchers believe that planets like K218b could support life because they may have certain properties that scientists call biomarker molecules. Biomarker molecules are simply traces of certain molecules of compounds left behind by organic processes. These biomarkers can be detected in the soil and water samples of a planet by space rovers or spotted in the atmosphere by telescopes and orbiters. Methyl chloride and dimethyl sulfite are common biomarker molecules. Some planets, however, can have elements like oxygen, methane, or hydrogen, especially if such elements are among the predominant ones on the planet. Life forms on Earth, however, are based on carbon, and carbon is the predominant element present on Earth. This would mean that organisms in worlds with no carbon would have a completely different structure from the carbon-based life forms we see here on Earth. If a planet's life forms are based on hydrogen, for instance, we may not be able to recognize them, especially using our own biochemistry as a parameter. Planets like Kepler K218b are one of a kind because they have the same biomarker as Earth, carbon. JWST revealed the presence of carbon molecules on this planet, as well as traces of methane and carbon dioxide. This puts K218b on the top of the list of planets similar to Earth with the potential to host biolife. But the Kepler isn't the only unique planet on the radar. One other famous but controversial candidate here is TRAPPIST-1b. This planet was discovered in 2016 and is about 1.5 times larger than Earth. Data also shows that this planet may be suitable for life. An astrophysicist from NASA named Thomas Green shared that this planet contains a dense atmosphere that shields its surface from getting too much heat or radiation from its star. However, the star is much too close to the star and receives much more light than we do on Earth. JWST revealed that the daytime temperature on this planet is over 200 degrees C. Again, this would be a suicide planet for humans, as we literally die from the heat. But it may be just right for some other kinds of species out there. Thankfully, with advanced space telescopes like James Webb, we now have the capability to examine the atmospheres of distant planets. Certainly, given the extraordinary discoveries made by the JWST in recent months, no doubt a series of mind-boggling discoveries lie ahead of us. In fact, some experts even feel that there may exist a planet somewhere in the universe with even more favorable conditions for life. These kinds of planets are termed super-habitable worlds. Imagine a world that is much bigger, sweeter, safer, and more conducive without all the troubles that we witness on Earth. Although it is merely a concept, super-habitable worlds would ideally be older, bigger, warmer, and potentially more humid than Earth. Experts in the scientific community speculate that such stars could be found orbiting around stars that are much older than our Sun, with longer lifespans. Our Sun, for example, is expected to last about 10 billion years. And based on our cosmological models, it took almost 4 billion years of life as we know it to develop on Earth. Some stars, however, can live much longer than 10 billion years. These kinds of stars will allow for a much more expressive and intensive evolution in their planets. So the big question now is, how do we find these perfect worlds or planets? Well, one theory many experts seem to agree on is to look for planets around orange stars that are cooler and less luminous than our Sun. However, these stars will need to have lifetimes ranging from 20 to 70 billion years. It is believed that life on planets orbiting such stars would have evolved to maturity, and so geological features and every element or bio-life forms would be at their peak. Certainly, such worlds would hold some superior benefits over ours, like more land area, longer-lasting heat sources, better protection against radiation, and perfect gravity. There's also a need for a superhabitable planet to have a mean surface temperature of plus or minus 5 degrees Celsius compared to Earth's, as this would allow for more diversity of life. So far, no planet has been found that matches the above description. But scientists aren't losing hope. At least the scientific community knows what it is looking for and where to look. However, many doubt that a world more perfect than Earth actually exists. Some conspiracy theorists feel like there is no planet better for human life out there than Earth. If such planets existed, we would have spotted them already. But then it's safe to argue that such technologies as we have today didn't exist in those times. So perhaps we hadn't seen such